Sometimes the smallest, quietest objects hold the loudest, most unforgettable stories. In the shadowed ballet of Saturn's many moons, one has waited, largely unnoticed, like a whisper among giants. But it's time to listen to that whisper. Because if you've never heard of Tethys, you're not alone. Yet you should know this. Tethys is a survivor, and her story is unlike any other. At first glance, Tethys might seem forgettable, just another icy satellite orbiting far from the warmth of the sun, trailing faithfully behind Saturn like a frozen pebble in a river of giants. But peer a little closer, and you'll see the scars. Deep ones, wounds that stretch around its very body, like the aching memories of a world that should have shattered, but didn't. Tethys is not just another moon. She is a record of violence, endurance, and ancient secrets locked away in ice. Orbiting Saturn from a distance of nearly 295,000 kilometers, Tethys moves through space like a ghost, pale and bright, caught in the perpetual dance of Saturn's pull. Yet this quiet moon bears one of the most astonishing features in the entire solar system, a canyon so vast it wraps around three-quarters of her body. Not many worlds, big or small, wear their pain so boldly. And facing that ancient scar, a massive impact crater, a yawning basin left behind by something that nearly obliterated her entirely. The moon we see today shouldn't even be here, and yet she is, standing, cold and defiant, in the face of impossible odds. This is the story of what Cassini discovered on the surface of Tethys, and why it left scientists stunned. It all began in 1684, long before rockets, probes, or space telescopes. The man for whom NASA's Cassini spacecraft would eventually be named, Giovanni Domenico Cassini, stood beneath the Paris sky and first observed this moon with the crude instruments of his time. Alongside Dione, Rhea, and Iapetus, he named these moons Stars of Louis, after King Louis XIV, a poetic gesture for a cold, distant world. But over time, the names faded, and the 19th century brought a new mythology, one inspired by the Greek Titans. Tethys, named for the sea goddess and Titaness, was reborn, fitting considering what she's made of. Unlike the rocky surfaces of Mercury or Mars, Tethys is almost entirely composed of water ice. Cassini, the spacecraft this time, not the man, measured her density with surprising precision. Just 0.97 grams per cubic centimeter, nearly the same as liquid water. That's less than 1% the mass of Earth's moon, even though she's roughly a third of the size. Think about that for a moment. This is a moon made almost completely of frozen water, not ice laced with stone, not rock hidden beneath layers of frost, just a solid, ancient, frozen ocean. This icy composition reveals something profound. Tethys may have never fully differentiated like Earth did. No molten core, no structured mantle, just an ancient blend of ice and dust, frozen together in time. And that, in part, is why she still holds together. There's something strangely beautiful about a world so soft, so fragile in theory, managing to endure in one of the harshest neighborhoods in our solar system. Her surface tells the rest of the tale. Bright, reflective, nearly untouched by the darker carbonaceous materials that stain other moons like Iapetus. Tethys shines like a pearl in the dark. Her surface reflects about 60% of the sunlight that hits her, an astonishing albedo that confirms her icy purity. But she's not a perfect sphere. Like a body pressed and twisted by unseen hands, Tethys is slightly squashed into a triaxial ellipsoid, shaped not by will but by gravity itself. And then there's the scar. They call it Ithaca Chasma. But no name, however poetic, can prepare you for the sheer scale of what this trench represents. Stretching nearly 2,000 kilometers long, 100 kilometers wide, and plunging 5 kilometers deep, this canyon is not just a feature. It is a message, a frozen scream. To put it in human terms, imagine a crack running across the United States from New York to Denver. That's how immense this is, especially when you remember that Tethys herself is only about 1,000 kilometers in radius. It is proportionally one of the largest canyon systems in the entire solar system. But what could possibly do this to a moon? The answer lies not in what hit her, but in what was happening inside. One theory, the most compelling by far, suggests that Tethys once held a subsurface ocean, a hidden world beneath her crust, liquid and secret. As she cooled over time, that ocean began to freeze. And when water freezes, it expands. Slowly, inexorably, Tethys began to swell. Not by much, perhaps only a few percent. But that was enough. The pressure built inside her shell, straining against her outer layer, until the crust simply split apart. Ithaca Chasma is what remains. A planetary stretch mark, a frozen monument to a time when Tethys almost tore herself apart just by the act of becoming solid. Other scientists have proposed that the impact which created the Odysseus crater on the opposite side of Tethys could have sent seismic shockwaves through her body, cracking the surface. But the timelines don't quite match. Ithaca Chasma is older. It speaks of an internal agony, not an external assault. That's what makes this moon so haunting. Her biggest wounds weren't inflicted from outside. They came from within. The surface of Tethys today is bitterly cold, around minus 187 degrees Celsius. At those temperatures, water ice doesn't flow like a glacier. It becomes as rigid as stone, holding its shape for eons. With no atmosphere to shield her, Tethys faces the full brunt of space, micrometeoroids, solar radiation, and Saturn's powerful magnetic storms. And yet, even in this frozen hellscape, she remains. A battered survivor still bearing the marks of ancient pain, but whole. And yet the worst was still to come, because not all impacts are micro. One was colossal, and it came with enough force to destroy her completely. But somehow, she survived that too. It's easy to forget that these far-off moons, seemingly frozen in silence and locked in distant orbits, have lived lives more violent than any human civilization has ever known. But one look at Tethys, at the scars carved into its icy skin, and you begin to realize that it's a survivor of catastrophic events that would have destroyed any lesser world. Imagine standing at the edge of a vast canyon that spans nearly 3/4 of the world beneath your feet. Not a canyon carved by wind or water, but one split open by pressure from within. This is Ithaca Chasma. It cuts through the moon like an ancient wound, jagged, deep, unforgettable. Stretching 2,000 kilometers in length, this crack in Tethys' shell is a monument to something primal and powerful. And it tells a story not of violence from the outside, but of struggle from within. In the earliest moments of its existence, Tethys was not the solid, frozen body we see today. It was warmer then, perhaps with a soft slush beneath its crust, or even a hidden ocean. But as the ages passed, the moon began to cool. Slowly, inexorably, the liquid within started to freeze. And here's where nature played its cruel trick. Water, unlike most substances, expands as it turns solid. As that internal ocean turned to ice, it didn't just settle, it grew. And with it, so did the pressure on the crust above. That pressure had to go somewhere. Eventually, the ice couldn't take it anymore. The surface ruptured, and out of that internal agony was born Ithaca Chasma, a wound so vast, so impossible in scale, that it's as if the moon tried to tear itself apart and then held itself together with the strength of its own will. The expansion needed to make this chasm? About 5% of Tethys' entire diameter. Think about that. A whole world swelling until it cracked open. This was not some fleeting moment in geological time. It was a transformation that defined the moon's character, its face, its fate. Ithaca Chasma didn't just happen. It became a signature, a permanent line written into the story of Tethys that no passing eon could erase. But not all of Tethys' scars come from the inside. Turn your eyes to the opposite side of the moon, and you'll find a different kind of violence. Colder, more sudden, and infinitely more brutal. Odysseus crater. Unlike the slow, tectonic agony of Ithaca Chasma, Odysseus is a scar left by an unimaginable impact. A blow so forceful, so cataclysmic, that it should have shattered the moon like a porcelain plate against a stone floor. Measuring a colossal 450 kilometers across, nearly half the diameter of Tethys itself, Odysseus is a basin so huge it defies logic. The odds were against survival. If the moon had been as solid then as it is now, The energy from that impact would have fractured it into drifting icebergs in Saturn's orbit. But luck, or perhaps timing, intervened. Tethys, at that moment, wasn't entirely solid. It was still in transition, its interior still partially molten or slushy. That softness, that internal give, may have saved it. Instead of shattering, Tethys absorbed the shock. It flexed, it yielded, and it endured. Even so, the crater didn't remain as it first appeared. Odysseus is shallow, almost deceptively so. Its once sharp walls have slumped. Its central peak has relaxed. Over time, the very ice of Tethys has flowed, not quickly, not visibly, but slowly over millions of years, like ancient glass melting under its own weight. This process, known as viscous relaxation, is unique to icy worlds. It's a gentle reminder that even things that look still, that seem frozen in time, are often in motion. And this crater, it didn't just scar the landscape, it transformed it. The force of the impact likely vaporized entire regions, blanketing surrounding areas with icy ejecta, burying older craters, erasing the past like snowfall over a battlefield. In one terrible instant, the entire face of Tethys was rewritten. It's easy to look at a moon like Tethys and think of it as dead, cold, inactive. But the truth is far more complex, far more dramatic. This isn't a corpse, it's a survivor. One that carries its trauma on its sleeve, bold and unashamed. And just when scientists thought they had a grasp on its history, something unexpected emerged. Something strange. In 2015, as Cassini made one of its many passes, its instruments locked onto something odd, an anomaly in the temperature patterns of Tethys's surface. At first, it was dismissed as a glitch, but when scientists looked again, and again, and again, they saw the same thing. A large patch on the surface of Tethys, covering the lower latitudes of its leading hemisphere, was cooler during the day and warmer at night than the areas around it. A thermal footprint that didn't fit any known pattern. When the infrared data was mapped, the shape that emerged gave everyone a chuckle, and then a pause. It looked like a giant Pac-Man. Yes, the arcade character from the 1980s. But this was no joke. This was a serious thermal anomaly, and it wasn't unique to Tethys. Mimas, another Saturnian moon, had one too. And like any good mystery, it begged a question. What could make part of a moon behave like this? The answer, it turned out, lay not on Tethys itself, but in the space around it. The culprit? Saturn's magnificent and sprawling E-ring, and the icy plumes from its moon, Enceladus. The leading side of Tethys, the side that always faces forward in its orbit, is constantly bombarded by tiny ice-rich particles from the ring. These particles are so small and so reflective that when they pile up, they change the thermal properties of the surface. They increase reflectivity, they alter heat retention, and in the end, they make the moon's face behave like a patchwork of hot and cold. The trailing hemisphere, meanwhile, faces a different threat: radiation. High-energy particles trapped in Saturn's magnetic field strike it relentlessly, darkening the ice, breaking molecular bonds, implanting ions. This space weathering creates a visible difference in brightness between the two halves of the moon. One clean, one scarred. One bright, one dim. All of this, the trauma of impact, the tension from within, the bombardment of ice and radiation, has shaped Tethys into a kind of celestial diary. Every mark on its skin is a paragraph, every crater, a sentence, and it is still writing its story. But this is only the beginning. There's more to uncover, more wonder, more silence, more secrets held within a frozen world that refuses to be forgotten. You might expect that a world as icy and ancient as Tethys would be entirely predictable, mapped, studied, understood. But that's the strange magic of Saturn's moons.